A tall smooth cylinder contains air at atmospheric pressure 1 times 10 to the 5 Pascal. So that pressure is 10 to the 5. The density of the air in cylinder is 1.2. So that's the standard density of air at surface level. A heavy piston is now placed on top of the cylinder and allowed to fall slowly downwards, compressing the air until the piston rests in equilibrium. So that piston, we'll push it in. And so this will exert its own pressure as well as that 10 to the 5. So the mass of the piston is 50 kilograms and its cross-sectional area is 0.02. So the pressure from that piston will be 50 times 10 for G. That's the weight, and then divided by the area, which is 0.02. So this will be the extra pressure on top, which is 500 divided by 1 over 50. So that is 500 times 50, which is 25,000 Pascal. What is the density of the air in the cylinder when the piston rests in equilibrium? Well, we can get that pressure times volume is a constant. And then, because we're not really using volume here, there should be another relation we can use. Well, they've given us a density, and then we know that the mass is a constant here. So we know that the mass, which is density times volume, equals constant. So the density is inversely proportional to volume, or the volume is inversely proportional to density. If we put that together here, we know V is kind of a 1 over rho. Then we know pressure over density is constant. So just substituted the fact that the mass term here will be constant, so we can kind of absorb that into the right-hand side, and we just get P over rho is constant. If you notice, the pressure has increased by 25% because we have 100,000 initially, and we added 25,000. So if the pressure increases by 25%, so will the density. So that means that the density, which is 1.2, which is just 1.2 times 10 to the 0, sorry. So I could ignore that. That's 1.2 times 1.25, which I can just verbalize as saying 1.2 add a quarter. So a quarter of 1.2 is 0.3. That is just 1.5 kilograms per meter cubed. So that is answer E. So I tried to do it this way, but you could also just use the fact that the pressure over density is a constant. So you could just say 10 to the 5 over 1.2 equals 1.25 times 10 to the 5. So that's 100,000 add the 25,000 from the piston over the new density. So yeah, as the piston falls down, the air will compress, and so it will be hitting that cross-sectional area more and more often. So there's a higher pressure, and then that pressure from the air inside will be balancing atmospheric pressure, and then the pressure due to the weight of the piston. So that's all we've been doing here, essentially. Let me know if you have any questions.